day ever to not record. Oh, hey, you missed 20 minutes. It was really important. Sorry. Luckily, Seth was on. Probably smelling Austin's feet right this minute.
We don't get a reaction.
No reaction.
Wow.
Okay. He's a noble guy. Gotten so much out of this. Okay, so the answer would be this one would not work because nitrogen cannot expand its octet to the D level. You have to be on the row 3 or lower to be able to do that. All right. Next. Okay, Si6, not the worst ever. S with 6 I's around it. It can have more than 4 because sulfur, once again, is in the 3rd row. Next, BH2 minus. I guess we have to put this as a negative. Going to violate because there's just not enough to fix an octet around boron, right? If there's not enough, you can't, so you don't. All right, Ni3. And this, you have 3 I's. You had 5 valence electrons here, right? You had 7, 7, 7. So we get 26. Ooh, we like the number 26 when there's 4 total things because that octets everything, right? Okay, and you can just see that right there. CLF plus, that doesn't happen very often. All right, so no big deal. Chlorine's pretty electronegative, but it still can be told what to do by fluorine, right? So that's why it's in the center. And the other common sense reason it's in the center is only one of them. So it's surrounded, we have an extra pair. If you have extra valence electrons, put them on the central atom. All right, you're allowed to violate that. And then we have this one as a -1. It's just the same. We kind of write this so far. The structure is not supposed to be.
So on the first one of this column, size 6. So how can it? So it can do 5 because of the D shell, which is like. So how can it do 6?
It uses the S as well.
Oh, okay.
They're weird. That's the real key. They have ST hybridization, is what we call it. We'll learn that in chapter 19. Okay. Next up, here you go. I would like you to take 8 minutes and draw as many of these as you can, and then answer this question. Would any of these molecules have resonance structures? Okay, try drawing these out. One of them, NO3, is a polyatomic ion with a -1. So remember to add 1 to total valence electrons. Okay, well, I'm going to pause this.
That's not a thing. Can I say it's not a thing?
I'm going to go. Let's go gold color. Let's go gold. I like gold. Okay, I'm going to put N in the middle. I'm going to put 3 H's around it. Are you okay with that? I'm going to connect them all with a single bond. I would never double bond an H. I'd be so mad at you. So mad. All right, and then
Say, get out of my classroom.
yep, get out. Go hang out in the box. Stinky feet. All right, so we have NH3 and 2 dots. I better check. Did I have that many valence electrons? Did I have 8? I had 5 plus 3. That's 8. Good. I'll move it on. All right, I mean, this is sleeping, so here we go. NO3 minus. Here we go. So You don't like that color?
I just don't like the light.
Don't change it.
Yeah, I just don't like that. Change it now, please.
Why
Like,
not change
make
it?
it listen,
Make it
it's
feel like a-
choose purple.
I've never felt so much peer pressure in my life. I grew up in the 90s, trust me.
Oh, there.
Oh.
No,
That one's worse.
Go blue. I think blue.
Oh,
Oh, I think it's.
No, light,
Yeah,
light.
there we go.
It's okay, we don't need to read it.
Boy,
Yeah.
that's hard to see. NO3 minus, you have an N, an O, an O, and an O. I do like this.
CS2.
These two.
What?
Okay.
You're gonna keep going.
So I'm gonna connect all of them. I'm gonna octet all the oxygens. And then I'm gonna try to complete the octet on nitrogen. Does all that work? Well, I got 5, 6, and then 3 times 6 is 18, so I have 24, right? We've learned, maybe, we need 26 to do this, so that's not gonna work, correct? So I gotta have a double bond somewhere, don't I?
Yeah.
All right, so I'm gonna get rid of this and put a double bond right here and get rid of that. Okay with that. Now, wait a minute. What is this? Resonance.
Yeah, that number. Or that word.
If I just take the thing where it shows the thing all.
For now, it's fine. Don't be on the internet, probably. I think you can still mark the drive, but I don't know. Okay, so that one did have resonance. Are we all right with that? Okay. Good. Okay, SF4.
I don't
Oh,
like.
is that SF4?
Yes, that is SF.
Oh, hold on. I can fix this, actually. I do have that ability. Okay, do I? Yeah, I'm all the way over here. I think I can just go like this. The magic of
Oh
technology.
my gosh.
This is the greatest moment. I went from such despair and bullying to just surviving. All right, I have 4 Fs here, around 1 S, correct? And this would be dandy. 1, 2, 3, 4, 5, 6, whatever. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I got to double check. This is great. Everything's octeted, correct?
No.
But do I have 8 times 4? 8 times 4 equals 32. How many valence electrons did I have here? 34. So what do I need to do?
Oh,
Put
I
2 on
do
sulfur.
that? Oh my gosh.
Yep. Do I care where they go, really?
Just not.
I
No.
didn't know you
But I
could just
put it
do
like-
that.
We just talked about that.
That way it looks like the.
I can expand because sulfur can have
Someone at
more.
least might
It's
know.
on row 3 lower.
Your little thing is shaky right now. Mouse.
My mouse, it's because I was shaking my leg. It makes my body shake. I will hold it perfectly still. I'm trying. I need that Instagram thing where your hand looks all weird. You're like, oh, Tom, you did like this. All right, C, S, S.
Okay.
Don't draw this. This is not right, but it would want to do this, correct? If life was perfect. But it can't because
Life isn't perfect.
we're short. There you go. Life isn't perfect. 4 plus 12, right,
16.
is 16, which is that. How do you draw it?
That's how they
But I've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20.
That's illegal.
That is-
That is
You
so
can't
bad.
do that, homies. So I just got to double bond it, right? Oh, I get rid of these 2. Okay with that?
What? No way.
Does it have a resonance structure?
No.
No.
'Cause it's just
Alyssa, was that a good mind blown or a bad mind blown?
I'm
Okay,
getting them right, but I don't know.
because I'm a really good teacher. It's the spirit of Seth. That's what's really helping me.
Is that good paying attention?
Oh, yeah.
All I know is I'm throwing an Oreo back and forth. It's an Oreo?
Maybe.
I'm
Is that
pretty
an
sure.
Oreo?
That goes really fast for an Oreo.
If I could, I would octet everything like this and be great, right?
Sure.
But can I?
No.
No, because I only have how many total valence electrons? 6 plus 2 times 6 is 12, which is 18. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I can't do that. I need a double bond somewhere, right? All right. Now
This one is
this one has
resonance.
resonance. Because the double bond can be on the other side. Fair enough?
Wait, so keep the 2 dots above the S and then the double bond one.
Yeah, there should still be, I didn't include the dots on this one. So
Right.
are we okay with that?
Yeah.
It's SOS.
okay, 5 fingers, 5, you got it. 1, you're completely lost on those structures. Let's see, give me a hands up. They gotta be higher. Sorry if you feel bullied right now. I gotta be able to see them, but I'm too lazy to move, so. Okay, Seth,
Hi, Seth.
Aw, peace out, dog. So what we're learning is it probably is harder to learn in the box than it is here.
How about you go over to the box and teach them
Okay.
there?
Okay, you got one right. Well,
Let's go.
you probably have no sleep and annoying people in there with you, so. Okay, that was hurtful, I apologize.
I don't think they can hear you.
Probably not. Okay, are we ready for math?
Oh,
If I was writing notes in my book, I'd put like a line. And I'd call this bond enthalpy. This is not bad, and it's not a ton different than what we've been doing. Trust me. Don't write anything super far down yet, or like, it's kind of chill. So bond enthalpy, we learned enthalpy in chapter 5. It's where we find the changes in heat or energy. Okay, so don't write anything here, but the most simply, the strength of a bond is measured by determining how much energy is required to break it. Okay, so this common, not common, diatomic molecules, what I'm looking for, to separate them into singles, like 2 that are separate, it takes energy. We call that the bond enthalpy. The energy required to break the bond. Okay, so for this one, it would be 242 kilojoules for 1 molar. So I could get these to come apart if I put in 242 kilojoules per mole. Okay. Now, bond enthalpies will be found in tables like these. So this table lists the average bond enthalpies for many different types of bonds. Average bond enthalpies are positive because bond breaking is endothermic. It always takes energy to break a bond. Are you okay with that? Okay, you don't have to memorize anything on this table. If this is on a test, which it will be, you'll be given these values. You just need to know how to use this. All right, next. Note, these are averages, not exacts. I'm just going to move on right here. Don't stress it out. Okay, so this is where we'll start doing stuff. Using the average bond energies or enthalpies of bonds broken or formed, we can estimate the overall enthalpy change in a reaction, or delta H of a reaction. We've done this before, just a different way. So in general, we can estimate the heat released from bond energies using this formula. We take the sum of the bonds broken and this is different than I teach you. It's okay, whatever. I'm going to put a minus here. Just trust me. It's broken minus 4. What? You don't trust me?
Yeah, no, I don't trust you.
I wouldn't either, but we'll be fine. So it's the sum of bonds broken minus the sum of bonds formed. I know why it says that. I stole this from the video, and I know why, but I'm going to ignore it. All right, here we go. We ready? So based on the bond energy shown in the table below, which of the following diagrams best represents the change in energy as the reaction proceeds? All right, so it will give you a reaction. The first thing you have to do is balance it, and this one is already balanced. The second thing you need to do is draw the Lewis structure. So it has H2. I'm going to draw this just right over here. I have H bonded to an H. You with me? All right, and then plus a chlorine bonded to a chlorine. That's pretty easy. And then H bonded to Cl. Now, if you felt like it, you can draw the dots here. For what we're doing, it's not required, but it might help you to review and make sure you write the correct Lewis structures, because they get more complicated than this. Okay. So in this reaction, we first balanced it, we then draw it, and then we come up with everything that was broken and everything that was formed. In this, we broke one H to H bond. Are you okay with that? Then in this, we broke one Cl to Cl bond. And over here, we had two. I didn't draw the two, I guess I should have. The two was from the balanced chemical equation. We had two H to Cl bonds. Are you okay with that? These are the bonds broken. These are the bonds formed. So now I substitute numbers in for the bonds. So right here, I have 1 times H to H is 430. Plus 1 Cl to Cl is 240. Now, I'm going to do the sum of all this. This is the broken, and then I'm going to subtract the form. I have 2 H to Cl, which is 430. Ready? $670 minus 860. 140. 190. What did I do so wrong? Negative 190. Right. Negative 190, which would mean this is an exothermic process. And that would be per mole. Well, it's just killing you. Don't worry about the per mole. I've done that twice now. All right. That's not the worst thing we've done all year. Okay, now let me explain this. This is from the AP video, and AP does not make mistakes. And I usually do, right? I know I'm right, and I know they're right. When you form a bond, that's an exothermic process. So just, we're not going to do it this way because it's more confusing to me. But they are adding, but this number is a negative. So just go broken minus 4. That usually will help you not screw up the sign. But that's why they had it up there. And if you watch the video, that's why you see it that way. Okay, are we all right so far? This is just, it's a little application of math, what we've been doing. Okay, so here we go. This is already balanced and drawn out. In the red dot, you can ignore that. That's just the presenter's mouse. So we've balanced it. We've drawn it. Now I'm going to look at everything that I do in this breaking, because we break reactions down, we break 4 C to H bonds. Is that okay? Where I got the 4 from? 1, 2, 3, 4 that I had to cut. Plus 1, 2, so 2 O to double O's. And then again, there's 2, 1, 2, 2 O to C double bonds, plus 1, 2, 3, 4 O to H. And then substitute in. So I have 4 times 4, 13. And I got that just right here. And then this chart is lowered. I need the O2. In the book, it doesn't do O double bond O. It just calls it O2. But that is the same thing. So this is plus 2 times 495 goes to 2 double bond O to C is right here, 799. Plus 4 O to H bonds is 463. And then I would take the sum of parentheses here of the broken minus 1. This is what you use to heat your water to take a warm shower today. So is this answer going to be negative or positive? Negative. This is an exothermic process. This is the energy released as methane was burned. Anyone have an answer for me? I'm not going to try to estimate. I'm super wrong. Negative 1500. Negative 808. I just guessed. All right, double check. Anyone else have negative 808? Yeah. So at your house, you get natural gas, comes out of the ground from a pipe, not really ground. It goes into your water heater. It is lit on fire. The fire breaks these bonds and makes these be reformed. When these are reformed, they give off. So that little spark, the teeny spark that lit your thing, caused this reaction to start happening, and it gives off heat so that it can make the water. Good enough? Okay. Uh-oh. They get more complicated. So here we go. We have the enthalpy of propene. I have C3H6. I've already balanced it 2966. So here we go. Are we ready? These problems, you just have to be good accountants. That's
Yeah,
they saw it. I have no idea what happened.
We did.
it was great. What happened to his face?
He landed his first try, though.
All right.
Is that a hacky sack or vegetable?
It's a cup.
They're on fire.
Let's go.
All right. So C3H6, if I remember right, looks like this. You okay with that? Okay. Plus, and there's an H on each one of these. Are you all right with that? Okay. Plus O2, that's just O double bond O, right? Goes to CO2. Hopefully remember O, C, O. That's super wrong. I can't do it myself. Oh, yeah, I can. Never mind. All right. It's a linear thing. You'll learn soon. All right, and then H2O would be HO. Now, I'm gonna come along and put their coefficients in. 6 of these, 6 of these, 9 of these, and 2 of these. Are you okay with that? Okay, now this is gonna get, you're gonna be really good at accounting. I'm gonna bring this 2, and I'm gonna put it right here. I have 2 of everything I'm about to say. I have 2, 1, 2, 3, 4, 5, 6. And that would be C to H bonds. You okay with that? Are you okay with where I got 2 and 6?
Yes.
All right, and you can do this in another way, it doesn't really matter. But I'm gonna put 2 again. 2 times 1, 2, C, double bond H. Or sorry, just double bond C. That's what happened when I tried to. Okay, that accounts, all this math is for this piece that was done twice. That's where the 2 came from both times. Okay, plus this one's not bad. It's 9, O, double bond O. Goes to 6, but there's 2 in each one, right? Times 2, C, double bond to O. Plus 6, but there's 2, 1, 2, O, single bond H. Very tricky. But now we plug in numbers and we'll sum this part up, right? Minus this part. So CH is 413. C double bond C was at 799. Oh, that's 614. This is the 799. C double bond O. That one is, oh crap, this was the, I'm struggling. Oh, the O is O2, which is 495, I'm sorry. And then OH was 465. So we have 12 times 4, 13. Plus 4 times 6, 14. Plus 9 times 4, 95. Minus 12 times 799. Plus 12 times 465. It is.
You need to put parentheses on around all of that.
It's not difficult, though, right? It's just, it's mind numbing and keeping track of the numbers, but not super bad. Does anyone give me a number here? I need to know. I have a -3. That's not right. All right, tomorrow we're gonna play with balloons.
Yay!
Everyone likes playing with balloons. Unless you're scared of balloons. Seth, we will miss you.